Bismillahir Rahmanir Rahim. Good afternoon and assalamu alaikum to all the participants. In this session, we have with us Professor Mohiddin Munawar Sahab. I would like to actually first of all thank Professor Munawar Sahab, who has agreed to actually deliver a talk in this session. We are, sir, honored to have you in this session. I would like to first introduce our guest, Professor Mohiddin Munawar Sahab. Since 1969, Dr. Munawar has been actively involved in Great Lakes research as a senior research scientist at Fisheries and Oceans Canada, Burlington. Dr. Munawar has published over 280 peer-reviewed papers and delivered over 400 scientific presentations, including several keynotes, plenaries, and invited presentations. He has published 2 original treatises dealing with the phytoplankton dynamics of the North American Great Lakes. His field of specialization is phytoplankton structure and ecology, microbial loop, planktonic food web, ecosystem health and management of the Laurentian Great Lakes. In addition, Dr. Munawar has convened and chaired many symposia and conferences across the globe. He has been professionally active on a global basis as the founder president of the Aquatic Ecosystem Health and Management Society, Canada, founder chief editor of Aquatic Ecosystem Health and Management, and also founder and editor of the EcoVision World Monograph series with worldwide distribution by Michigan State University Press. He has organized and edited more than 50 special issues of the Aquatic Ecosystem Health and Management on various topics. In addition, he has edited more than 20 books on a variety of ecological, environmental, and ecosystem science topics. Dr. Munawar has received several awards and distinctions, such as the Chandler Messner Award for the Best Scientific Paper of the Year, IGIA-GLR 1978, the Anderson Everett Award for Lifetime Contribution to Great Lakes Science by IAGLR 1998, Honorary Doctorate, Dr. Honoris Causa from the Gothenburg University, Sweden in 2007, Assistant Deputy Minister's Distinction Award by Fisheries and Oceans Canada in recognition of his excellence, leadership, and scientific contribution in 2007, Fellowship of the Academy of Science, Engineering and Technology in 2008, Lifetime Achievement Award for Great Lakes Science by IAGLR in 2012, Honorary Fellowship by the Inland Fisheries Society of India, Kolkata in 2013, Jack Valentine Outreach Award by IAGLR in 2019. He has published several AEHM special issues on Indian inland waters, including majestic river Ganges and major rivers of India. With this introduction, I would like to request Professor Mohiddin Munawar Sahab to deliver his talk. Professor Munawar Sahab, please.
Yeah. Assalamu alaikum. Good evening for you and good morning here. It's about 8 o'clock in Canada. I want to thank Dr. Samiullah for his persistence in inviting me, because in the beginning I told him I'm not available. It's a very busy life, and due to COVID, things have been difficult. But anyway, he persisted, so I gave in. I like to thank him and the Kashmir University, the organizing committee, for giving me this privilege to address this webinar, which is devoted to the World Water Day, initiated 25 years ago by United Nations in 1993, with a focus on what water means to people, its true value, and how we can better protect this vital resource. So when Dr. Samiullah invited me, I didn't want to just show off what we are doing here in Canada. We have a long history of research in the Great Lakes, Great Lakes are huge. They constitute 20% of the world freshwater resources. So I wanted that my presentation should be useful for India. The research should be applicable. Then I started comparing the research. Then I found out there are many similarities between the aquatic ecosystem of the Great Lakes. There are 5 Great Lakes, and then India is a land of rivers. The river Ganges and Brahmaputra, and then Godavari, Kaveri. I'm aware of all these names because when I grew up in India, I read all these things in the geography. So I started looking at my data and the data of my department to see how the Canadian research on the Great Lakes would be useful for the Indian young and budding scientists. Then I realized that Ganges has got serious pollution problem. It originates very well from the Himalayas, but it becomes messy by the time it comes to Varanasi and then goes down to the Bay of Bengal. So my presentation today is humbly attempting to compare what is happening in the Great Lakes and then how it could be used in Indian water. So the objectives are inland waters are under threat throughout the world, not only in India, but everywhere else. So we will discuss the application of ecosystem approach to the restoration of inland waters of India, how the knowledge from the Great Lakes could be transferred to India in a simple and easy and inexpensive way, review almost 50 years of management practices and strategies in the North American Great Lakes. We'll deal about phosphorus abatement program and how the beneficial use impairments have been defined in the Great Lakes and how they have been assessed for recovery, and how the Great Lakes science could be transferred to India and other countries. India has got 4% of world surface fresh water to support 18% of the world population. And on the right side, you can see freshwater comprises only 2.5% of the world water resources, and most of which is there in the form of glaciers. So the next slide shows what are the stressors and threats. One of the topmost threat is eutrophication, invasive species, climate change, loss of biodiversity, loss of wetlands and coastal zones, degradation of fish habitat, overexploitation of fisheries, and pollutions and contaminants and hydrocarbons. Great Lakes are huge. They constitute 20% of the world water resources. They can be seen from the space. This is a shot of the Great Lakes. You can see Lake Superior, the cleanest of all the lakes, the largest lakes in the world, on the top, connected to Lake Huron and Lake Michigan on the American side, Lake Erie and Lake Ontario here in Canada and Ontario. This is just a size comparison. You can see that these Great Lakes, Superior, Huron, Michigan, Baikal, along with the African Great Lakes, Tanganyika and Victoria, are the largest lakes area based on square kilometers. We define a large lake which is 500 square kilometers. So you can see most of the Great Lakes on the top of the list. They are young. They are only 10,000 years old compared to the African Great Lakes, which are millions of years. They occupy 250,000 square kilometers. They are home to almost over 40 to 45 million. This is an older slide. Are people using over 60 billion gallons of water daily. They constitute about 40% of US and 35% of Canadian agriculture. They consume a lot of fish. They export 25 million of tons of cargo annually, and manufacture. They are the heartland of manufacturing in the Great Lakes. These two personalities, you might know their name, Dr. Nolan Weider on the left and Dr. Valentine on the right. These are the outstanding genius or the major contributors to the current sciences being applied in the Great Lakes. Nolan Weider is known for his phosphorus abatement model, which contributed to the water quality agreement. There is a water quality agreement between US and Canada, which is based on about 100 years of agreement. The first treaty was signed in 109 years ago. He devised the first biological lake-wide program. On the right side, you have Valentine. He is also responsible for initiating the phosphorus abatement program, contributed the ecosystem approach, which is still valid in the Great Lakes Water Quality Agreement. His ecosystem approach is famous for his comprehensive and holistic treatment of the Great Lakes, recognize complexity and interconnections, interactions of social, economic, biological, physical, and chemical system, full range of consequences, anticipate ecological change, like COVID is an ecological change. You are supposed to anticipate ecological changes. So this pandemic is an ecological change with the advent of an unknown virus, recognizes that humans are an integral part of the globe. All this contribution from these two gentlemen who are no more with us contributed to the Great Lakes Water Quality Agreement to restore and maintain the chemical, physical, and biological integrity of the lakes and virtually eliminate the discharge of any all persistent substances. Compliance under the agreement relies on the goodwill and action of each nation. These agreements were signed in different times of in the past. The first one was 1972, then 78 and 87 and 2012 with different reflecting developing science and techniques and concept. This is the classical eutrophication model, which he produced by taking primary production data, phosphorus loadings, chlorophyll, and we were just lucky, me and my wife contributed phytoplankton data for all the Great Lakes to confirm his model. Based on this model, he calculated how much of phosphorus should be reduced in the Great Lakes to improve the eutrophic status to oligotrophic and mesotrophic, and that is being still followed. And you can see on the right side, you have the distribution of phosphorus from 1970 to 2012, particularly the lower graph shows the decrease of phosphorus from almost 30 to 50 micrograms to down now to 10. The phosphorus content today is very low, less than 10 micrograms, and we think the phosphorus concentration has gone too low and may not be enough to produce phytoplankton and modify it through the food web into the fish. This is the, they call it plankton ladder. This was also developed at the same time when Vollenweiser was developing his model based on primary production and phosphorus. This takes phytoplankton biomass as the basis, and you can see that on the right side, it classifies the lakes from ultra oligotrophic lakes like Lake Superior to highly eutrophic lake like Erie. This shows the long-term changes of phytoplankton from 70 to 2018 for different groups of algae, which were used as indicators of eutrophication and oligotrophication nowadays. And we still monitor it in all the lakes. These are some of the micrographic shots of some of the species. To the left, you have green algae, you have flagellates, cryptomonas, Ancystodispersa. Some of them are already there in Ganges waters. These are some diatoms. The Great Lakes is known for the abundance of nanoplankton, flagellates, small species in most of the clean lakes, and then filamentous diatoms like Fragillaria and other larger species in polluted waters. The next phase of research was the identification of areas of concern. The research committee defined 42 areas of concern distributed from all over the Great Lakes based on 14 criteria. These are known as beneficial use impairments. These beneficial uses from restrictions of fish and wildlife to tainting of fish and degraded fish, bird or animal deformities. I just want to skip all reading all these. Restriction on drinking water, beach closings, phytoplankton and zooplankton health, clarity of the water, development of algal blooms. All these criteria were known as beneficial use impairments. Any of these which were not shown by the by various areas of concern, usually they are nearshore areas, were called areas of concern, and then both the governments in US and Canada developed program of the cleanup, and thus the classical remediation and restoration program, which lasted 35 years ago and still is continuing in some of the places. This is the biggest research effort ever done by investing billions of dollars by both the governments of Canada and US. This is just an example of one of Canadian research in one of the areas of concern called Bay of Quinte, where you can see the phosphorus was high, about 35. Chlorophyll is about nowadays is 11.5. It was higher, 20 to 30 before. This shows the effect of phosphorus abatement from high values in 1970 to coming down now in 2015 and 18 to lower levels, which is making the Bay of Quinte lot cleaner than it was there before. This shows the fall of chlorophyll due to abatement. This shows the phytoplankton biomass. That line there is the target of how it should be low in the bay. On the top left is the classification using the phytoplankton ladder I mentioned. This is the model for primary production. We sample this bay of 20 every 2 weeks. We again monitor the species composition. On the right side, we use the plankton IBI index to see the status of the Bay of Quinte. These are some of the harbors. We followed the same techniques of eutrophication model, species composition, nutrient measurements. I think the emphasis, we will see later on how this data compares with that of done in Indian rivers, especially Ganges. This is a comparison of how Lake Ontario, which is supposed to be clean, mesotrophic to oligotrophic. Toronto Harbor, which is little bit polluted, and then you have Hamilton Harbor and Bay of Quinte. I just discussed. These are highly polluted eutrophic ecosystem, and you can see that it shows higher trophic total phosphorus content in these polluted areas. The next slide shows here the chlorophyll. Again, chlorophyll is higher in the eutrophic ecosystem and lower in other areas. This shows the primary production. Primary production is another indicator. We use multiple indicators. We use chlorophyll, phytoplankton count, primary production using carbon-14, and you can see that less than 5 micrograms milligrams is the indicator of oligotrophy, like in Lake Superior. Oligotrophic to mesotrophic is 5 to 25. Eutrophic is 40 milligrams, which is very common in the Ganges. You will see later on our comparison. This is the gradient of the phytoplankton. So all these multiple parameters are confirming the results of the trophic status, which is based on Wohlen-Weider's model and based on the phosphorus abatement program. Other than the water quality, we have sediment pollution in the Great Lakes, same in Ganga. So we can compare. We have several rivers in the Great Lakes which are very similar to large rivers of India, like Ganges, Brahmaputra, Godavari, Kaveri, and I mean India is a land of rivers. You don't have too many lakes like we have. We have lots of lakes, but we have also sufficient number of rivers, which some are clean and some are polluted. In the Great Lakes, we have Detroit River, we have Niagara River, we have St. Lawrence River. These are part of the system connecting all these large lakes and carrying the navigation from Europe, connecting to Atlantic Ocean and taking all the cargo up into Detroit, Chicago, Toronto, and up to the Lake Superior. So it's a pipeline for maintaining the economy of both the countries. The sediments have serious problems. We have problems of metals, organic PCBs, pesticides, tremendous similarities with River Ganges. This is the outline we follow in the Great Lakes. We assess the ecosystem health by doing structural assessment, by looking at microbial loop, phytoplankton, zooplankton, benthos, fish. When we're doing the functional assessment, by doing primary productivity, you just saw bacterial growth, and then phosphorus uptake. Then we divide the assessment into two parts: waterborne toxicity, sediment-borne toxicity. Waterborne done by using phytoplankton. We divide them into non-toxic and toxic. Same thing applies to Ganges, because Ganges has got a lot of sediment fluxes problem, particularly in the mid reaches. Sediments, again, like the Great Lakes rivers, in St. Mary's River and Detroit River, we have serious sediment problem. So there is a toxicity program, which is also badly needed for Ganges. I don't see in the literature much has been done on the sediment toxicity. You only measure metals and pesticides and organic chloric PCBs, but nobody is testing their toxicity, particularly by the heavy use of the rivers for various human activities. So this is just an outline. You'll see later on what am I proposing for Ganges. So we use testing species in exposing worms and amphipods and Daphnia, and we measure their mortality to water illiterate form of sediments and solid sediments. Then we measure the response of phytoplankton by fractionating them into three sizes, because the phytoplankton is smaller sizes, like less than 2 microns, and nanoplankton, these are more sensitive than net plankton to the water and sediment toxicity. So it's very interesting data. It would be very useful to apply this kind of technique to the Ganges. So these circles show you the major rivers. So these are the St. Mary's rivers, connects Superior to Lake Huron. It has pulp and paper mills used to once upon a time. This is the Detroit rivers. This is affected by car industry. All the American cars are made and dispose their pollution in the Detroit River, connecting Lake Huron and Lake Erie. Lake Erie has got other problems, agriculture waste, and then Lake Ontario, Toronto. Burlington is located very near Toronto, about half an hour drive, and this is the longest river of the Great Lake system. St. Lawrence River connects to Atlantic Ocean, the gateway to the Europe. This shows you some results of the St. Mary's rivers using phytoplankton and sediment assays, using animals, Hyalella and Lumbriculus. Based on this, recommendation were made to various committee. You see now the same experiments are being done by Detroit River at all these stations, both waterborne toxicity up here with different size fractions, and then sediment. It looks very complicated, but once you start doing it, I think they are kind of exciting to do this experiment. Go to these rivers, collect that material and put it on the bottles. You bring the sediments to the lab and process it in the lab in your incubators, and then do the counting. This is the same type of experiments, and using primary productivity on the left side in 1989, and then various stations were sampled across the river, connecting Lake Ontario to the left, and then estuarine area. Here is the the great city of Montreal, and then it merges into the ocean and clears the water from the Great Lakes into the ocean. So this was all about Great Lakes that really reflected almost 50 years of research. It's all started in the Great Lakes in the 1970s, and now it's about 50 years. Lot of development, like starting with the eutrophication model, then nutrient surveillance, then applying the food web approach. We didn't want just the fish or just the phyto. We wanted to monitor the whole food chain from bacteria to phyto to zooplankton to benthos to the fish, and look at the whole food web, not just fish because we like to eat the fish and because it becomes the money. So in order to maintain the ecosystem health, it was necessary to take a food web approach and then the areas of concern. So this gives you a trip down memory lane of 50 years. So let's see what's happening in India. This is the map of India showing the network of Indian rivers. You know Ganga very well. It's Yamuna and the Sangam in Allahabad, and then it flows through Varanasi, Bihar, Meghalaya, then it merges near Sundarbans in Ganga Sagar to the Bay of Bengal. Is this area, Barakpur, is very famous. That's when the British brought the arms and ammunition to kill the Indians at that time when they occupied India. So that Barakpur still is called Barakpur. I think they should change the name because it has bad memories of aggression. Anyway, so these are several rivers. The AEHMS has published a special issue on major rivers of India, which covers the ecosystem health of 14 rivers. Published sponsorship of CIFRI when Dr. Sharma was the director at Calcutta. This is different uses and scenarios of river Ganges, which has been called majestic, which has been called mighty. This is the origin in Gangotri in the glaciers and follows through the plains and then comes into the whole area from Allahabad to Varanasi here. This is a shot of all the stations about which much is known, and the Ganges is divided into 5 regions: the Great Himalayan region, the Shivaliks, Gangetic Plains, Southern Hills and Plateau, Sundarbans and Delta. Is a complicated system. It is shared by 5 states: Uttarakhand, Uttar Pradesh, Bihar, Jharkhand, West Bengal. I think this is, I'm mentioning it not just because to talk about geography, because all these states have their own rules and regulation. They all the users of Ganga, they are responsible for making it polluted and to make it clean. So they had to cooperate. And in America and Canada, we have this agreement between the 2 nations. What is needed in India is to have an agreement between these 5 states and the Indian Union, so that the pollution could be monitored against some guidelines like areas of concern. So anyway, this is the geography and of the Ganges. The Ganges is you might know all these things, but I think since we have international audience, I thought of giving it some outlines to make them relevant. So the top stretch consists of Bhagirathi and Ganga and Alaknanda rivers. Then you have the stretch through which Bijnor and Kanauj and Kanpur, Allahabad and Kanpur are very famous. Mirzapur, Varanasi is famous. There you have the great gatherings and many cultural activities take place. Then you have the lower reach, stretch number 3, Farakka, then Kolkata, Ganga Sagar merging into the ocean. This shows you the current status of the degradation of the fish. This is the fish harvest. This is from the paper from VAS published in AHM in 2010. You can see that the harvest of the fish has been going down the hill. This is the data until 2003, and there's a shift of composition due to increasing population in the Ganges. This is the current status of the phytoplankton. There are so many here. There are 20. The quality of the data on the phytoplankton is not acceptable internationally. It gives you only the genus. It doesn't give you the species. So the genus really is very superficial indicator of any starter. But anyway, people have tried to indicate that the chlorophyceae, the second column, and cyanophyceae, the third column, they are the polluters of they are the indicators of pollution. We call it eutrophic indicators, are dominant in Ganges, and you can see some of the picture: Pediastrum, Anabina, Spirogyra, Alococera. These are all indicators of pollution. They are not clean species. So their presence shows that there is a serious problem with the lower food web. This is the most interesting slide of the presentation. My colleague who's online, Mark Fitzpatrick, plotted this. We compared Ganga and the Great Lakes for major parameters like total phosphorus, primary productivity, and nitrate, which is one of the major nutrients for photosynthesis. And you can see that Ganga, the estuarine region near Calcutta, has the highest phosphorus, about 250 micrograms. That's too much. Even upper reaches, middle reaches, lower reaches are having total phosphorus higher than 30 micrograms, which is the limit of eutrophic. So all these 4 reaches, particularly estuary, are already eutrophic. Primary production, you can see that upper and middle reach is quite high. Even lower reach is higher. Is the indicator guideline is 50 milligrams, so you can see it's higher. Because of algal blooms and other pollution, the primary production very high. How does it affect fish? We have to collect the whole food web data to see how this degradation is reflected in the fish harvest. Nitrate, is supposed to be 10 micrograms, and you can see in the lower estuary and an estuarine region, nitrate is higher, and so these are the guidelines. We are proposing through this presentation that instead of using BOD, which is more expensive and everybody cannot do, we should measure the Great Lakes techniques like phosphorus, primary production, other nutrients, chlorophyll, phytoplankton. These are cheaply done. Follow the right kind of technique, modify the phytoplankton technique to better microscopic technique, have higher levels of taxonomy so that you can identify the organism until the species. Collect data which has a successful story. You don't have to worry about it. You don't need too much of money. You need to follow across the rivers. You can see that this is the primary production distribution from Gangotri via Hardwar, Narora, Kanpur, Allahabad, and Varanasi. You can see Allahabad and Varanasi are very high because of high rates of pollution. And then that is also supported by the amount of chlorophyll. Chlorophyll is high in the lower reaches also near Tribhuvan. These arrows are our suggestions for future workers of Ganges to have index station, have permanent index station to measure primary production, phytoplankton, chlorophyll, total phosphorus, so that you can monitor the ecosystem health of the rivers on a ongoing basis, and have long-term data, just like Warren Weider, and you can do the modeling. All this goes into a model to determine how much of phosphorus should be disposed of in the river. This chart shows you the same, I call it Ganga areas of concern, GAC. That's your acronym. So we have about 10 Ganga areas of concern, 3 in the upper reach, 4 in the middle reach, 3 in the lower reach as index station. And these are the names of the areas where we are proposing. So I hope there are this presentation encourages some students and faculty in Kashmir, in other parts of India, to apply this easily available and successful stories for the recovery of Indian River. Now, this is a proposal summarizing what I just told. You have to monitor in Indian River eutrophication. That means nutrients, phosphorus, nitrate, nitrites, silica, chlorophyll production, phytoplankton, biomass composition. Then toxicity we measure by bioassays, water, as I described to you in the Great Lakes, and the sediment, liquid phase, solid phase, and all this data I put together to assess the ecosystem health of River Ganges. This is just an example of River Ganges. You might know some rivers, or I know River Dal Lake. You are Dal Lake in Kashmir. I was in Srinagar in 2007 in a conference, and we toured Dal Lake, and there was a discussion how to clean up Dal Lake. All these techniques could be applied to its streams. They're beautiful, and Kashmir is one of the most beautiful part, and known about it since my childhood. So all these techniques could be applied to Kashmir or anywhere in India, to River Jamuna, Godavari, and Narmada. There are so many rivers, and I think it will be very exciting that we can encourage young researchers to adopt this kind of approach. These are general, you can get it anywhere. How do we deal with Ganges pollution? Management of untreated sewage, monitoring of industrial discharges, zero discharge or moving of industrial outlets to some other remote places away from Ganga, manage agricultural activities, change from pesticides to organic mode, monitor pharmaceuticals or hormone discharges, maintain minimum flow for diversion projects. This is all available in the literature. I just summarize it. Ecosystem-based approach by integrating science, society. This is our contribution from the Great Lakes. Implement bacteriophages and metagenomes studies, and maintain dissolved oxygen, a minimum of 5 milligrams. assess cultural and ritualistic releases in the river, change cremation practices, stop disposal of waste, establish index monitoring station, which I just presented, establish protected areas, banning anthropogenic activities. I think the bottom line is that you have to have an ecosystem approach. You cannot just control pollution by doing experiments and doing models. The public and population has to exercise care and cooperation like we are doing in controlling the pandemic. Everybody in the whole world has to cooperate by social distancing, by masking, by monitoring. So environment is just like another smaller pandemic that all have to unite together and apply the ecosystem health approach. So in conclusion, so ecosystem base has been successfully used for 50 years in the Great Lakes. Agreements on water quality between member states surrounding Ganges is recommended based on Great Lakes experience. Phosphorus should be used to classify health of the Ganges, not BOD. BOD is not that specific. And then you already have a successful story in the Great Lakes and the rest of the world. Phosphorus is not the only one control in Canada and US. It is being controlled in Europe, in Africa and parts of Asia. Eutrophication models are common for Bolumweider. We are proposing Ganges areas of concern so that you have a long-term persistent data of the same parameters for modeling purposes. And these lessons are applied not only for the Ganges in India, but throughout the world. Let me tell you in ending my presentation that AEHMS has been very active throughout the world in promoting this ecosystem health approach, remediation, restoration, and techniques. It has taken a lot of interest in developing countries, in Africa, in the African Great Lakes, Victoria, Tanganyika, Malawi, in India, collaboration with particularly with Dr. Vas and Dr. Sharma later on, and CIPRI, we have done a lot of conferences. And of course, being from India, I showed a lot of interest in bringing India on the map of world research. So the society does timely international national conferences and workshop, establishes working groups like we are hoping to establish a working group in Ganges to homogenize techniques and give training sessions. We publish a primary journal, Aquatic Ecosystem Health and Management, from between Canada and the States. We also publish books, peer-reviewed books. The journal publishes concise papers, which a lot of Indian authors have done in major rivers and Ganges and on Godavari and Yamuna. There are 14 rivers we publish already. That's the most extensive record of the ecology of Indian rivers published by any other journal in the whole world. We invite essays from senior scientists, experienced people to learn from their wisdom. We do special issues. We have done, we do books. These are some examples of the books, monographs. We have published about 5 special issues from 2001 to 2017, about which I already talked to you about Great Himalayas ecology and tropical temperate regions. Of course, 2 issues on Ganges, 1 on the major rivers. So these are heavily downloaded by the people. And actually Ganges papers by Dr. Vas on fisheries and by Dilip Kumar, the culture of Ganges is the most downloaded papers of the journal for the last 5 years. These are upcoming issues by the society. We just had a conference in Pantnagar in Uttarakhand last winter, just before the COVID started. I came back from India, and then after 1 week we were locked in. So we are, as a result of this Pantnagar conference, we are having 3 special issues on invasive species with Dr. Singh, and on climate change with Dr. Sarkar, and on Pantnagar with various people. Our other upcoming issues is there on African Great Lakes, on social, cultural, and economic ecosystem services. And then we have planned a special issue in the developments and improvements of modeling techniques in freshwater. You can see the modeling is so important because COVID is managed by modeling of the infection rate. One of the, although COVID is bad, one of the advantages is that the governments have learned how to apply science and modeling in the management of politics, this is a tremendous development. So I think I'd like to once again thank all the organizers and Samiullah, and I'm glad he persisted. The life is so busy here, particularly due to COVID. I rejected him 3 times. I felt bad about it, but 4th time he persisted. So then here I am, and I hope there is a message of transfer of approaches and technology. I hope it will generate interest by the Indian scientists, and particularly with the young students, graduate students. I hope it will be, this transfer of science will be useful in application to Indian situation. We tried to use simple and easy and inexpensive approach so that not too much of money will be needed. You have long rivers, so you have to work hard, and working hard is always fantastic and exciting. Thank you very much.
Thank you, Professor Mohideen Munawar Sahab, for sharing the experiences that you have actually shared, experience of all that is actually spanning over a period of 4 decades while working in the Canada. I think it was a thought-provoking lecture for the youngsters as well as the faculty members here. Would you like to allow us actually to take a few quick questions from the audience who have actually put certain queries in the questions vis-a-vis your lecture?
Okay, no problem. I love questions.
Okay, that's it. I think we will take a first question from Mr. Shahid Damadar. His question is regarding what would be the overall trophic status of a lake when only 2 parameters are assessed, that is when chlorophyll concentration reflects mesotrophic nature and phosphorus reflects eutrophic nature of the lake. In that situation, what will be the overall trophic status of a lake?
Yeah, well, normally all these parameters, as I showed you, about 4 of them, they confirm each other. You don't have contrasting data. If you have contrasting data, that means there's something wrong with the technique or sampling. You have to be very careful. The same standard sampling techniques are done, but normally chlorophyll, primary production, phosphorus, all these confirm with each other. We didn't see any high chlorophylls and low phosphorus, or vice versa. So then you should check your techniques. How your techniques are there? Is there any contamination of some kind that you are getting high data? The best thing is to see the odd layers. When you bring the data, multiple trophic data, look at the data. That's why it's important to look at long-term data, multiple parameters. So any outliers, you should check it out. Why the values are low or high. I always look at high and low value. Mark Fitzpatrick there in the audience knows. I quickly go and say, why this is high? And he says, I knew that you are going to ask about it. I have explanation. So this doesn't happen. And if it happens, you should look at your methodology.
We have one more question from Asifa. He's asking for the phosphate has a major contribution in primary production of lakes, which ultimately leads to increase in the fish production. Can we accept it as a better thing to have phosphorus in excess level?
Well, I think that's where the modeling comes. I think our modelers have estimated, and that's what I'm trying to emphasize. When you have this chlorophyll, phosphorus, and production data, you will know how much of phosphorus should be there. You should estimate by modeling the amount of acceptable phosphorus level, which will give you moderate harvest of fish. And I think cutting down too much of phosphorus will cut down the fish also. So you got to estimate from your research what is the acceptable level of phosphorus which will produce healthy fisheries. This is a very old question, and it's a very good question. So we in Great Lakes have various modelers. We have modeling from phosphorus to fish. Fish, total harvest, what kind of fish? Some species like low phosphorus, some species like high phosphorus. And how does it affect the grazing of zooplankton of the phyto and then the grazing by the fish? So you have to we have to adopt not just fish, you have to adopt the food web approach, the food chain. So like Varanasi is full of mess. You know, and primary production is so high, over 100 milligrams. That's unbelievable. It's not tolerable here more than 50 milligrams, as I showed you in the graph. So you got to determine that all this extra productivity, where is it going? What is it doing? We don't know in Ganges. What is that high chlorophyll and high production is doing? We only know it exists. So how does it very high primary production and phosphorus affecting the nature of fish? Now the special issue in invasive species with Dr. Singh is telling that the harvest is going down. The species composition is not for good species, but for bad species. I'm not a fishery person. The fish expert says that the species composition of Ganges River is bad. A dolphin has disappeared. Now due to COVID is coming back. So you have to look from an ecosystem perspective. What is good? Don't just take phosphorus and just fish. Total harvest. I know fish is the pulse of the Indian fishermen, and a lot of poor and rich people depend on fisheries. So you need to apply a modeling approach, an ecosystem approach. You have to see what is really good amount of phosphorus which should be dispersed. Right now, I think anybody will tell you that what is happening in the Middle Ridge is unacceptable from any international standards. And I'm surprised there's not too much emphasis is given in India on phosphorus abatement. They go on BOD. BOD is used only mainly in wastewater treatment over here, not for the lake or river management. I hope I answered.
Okay, we have observation from our participant, namely Muhammad Sharjil Sofi. As policymakers have failed miserably in managing the rivers of India, I believe that large rivers should be declared as the property of the defense for their maintenance. What are your views about it?
I don't know what the defense has done. Are they disposing of things in Ganges? I mean, how does the defense come in? Are they have some disposal from their material. I mean, I think I don't know how you think that phosphorus has failed. Maybe the people the managers who applied the phosphorus, I had to see the document in what way the phosphorus failed. We have a record of 50 years, Canadian, American, European, Chinese data which shows the abatement of phosphorus is really good in control of eutrophication. We have to find out the amount, how much should be the minimum limit allowed. So if you say it's failed, I don't know what you mean by failing of phosphorus. High phosphorus is not good.
Okay, we have one more query from the Umaira Qayyum. She's asking, up to what extent can we change the status of an eutrophic lake back to the oligotrophic, especially if it is an urban lake?
Well, I think it depends what is the uses of the water is important. It is for agriculture, is it for drinking, or is it for just some cultural activities? So you decide how much of, I mean, we recommended 30 microgram based on our data. Maybe the 30 microgram is too low for India because you already have very rich phosphorus in most of the rivers, as I know, based on the papers we have published. So actually, I don't know. Somebody in your various departments work, agricultural department, geography department, public health, whoever manages the phosphorus limits in sewage disposal, they should decide how much should be permissible for whatever use. So use of the water is very important. You know, drinking water has high standards than for agriculture. The plants doesn't need very clean water. You know, for industrial uses, some kind of pollution is allowed. So and to clean up the phosphorus is expensive undertaking. So it all depends on planners and managers and collective opinion of the committee. That's why you need to have ecosystem approach. We have scientists, we have managers, you have public health people, and you have modelers working together. India has got a lot of modelers. India is good in mathematics. I know because when I was as a student, you know, either you become a medical doctor or you become you take mathematics. And those who are weak in mathematics, they go to biology. You see, here in the West, there is no such division. Anybody can become anything, and they don't all want to become a doctor like the Indians wants to. But here you see in Canada, majority of the doctors are from India. Here, even now in Toronto, all the COVID is being managed by Indian doctors and other doctors because of the cultural heritage. You know, everybody wants to become a doctor because it makes money, not that they want to help the humanity. You know, it just you become rich. You get married in a rich.
We have one more question from the Zahid Wani. Can we clean up, stop, or end the harmful algal blooms from the lakes? What methods could be used to clean up algae bloom from the lake surface?
I mean, I think it's too late to clean up algal blooms. I mean, you'll have to physically remove the algal bloom, but the control algal bloom is the nutrient abatement, which I presented. In this thing, it's already proven that is N and P and silica are the three nutrients which manage the algal blooms. You know, so it's not just phosphorus. You know, how much of silica is there to produce diatom algal blooms. The algal blooms are different types. Blue greens, chlorophyceae, which you have in Ganges. Ganges has chlorophyceae and blue greens, cyanophyceae. So you physically, I think I never heard anybody removing or harvesting the algal bloom. They are so minute. You just cannot, unless they are filamentous algae, you can remove them by some equipment, but they are all microscopic. It is very difficult to clean up algal blooms unless you clean up the source of pollution, which is nutrients, and where they are getting the seeds. Where are they getting the contamination? It's coming usually from outlets, from tributaries, from rivers, and other agricultural ways. So you have to look, what are the agricultural ways? India has a lot of work to do. It's just not the Ganges. All the rivers are a mess. You know, I'm using this word because everywhere you have pollution and ecosystem health is questionable. I think the Ministry of Health, I don't know which.
I'm having trouble hearing you.
Yeah, so Ministry of Health or Ministry of the Environment, whoever is managers, I think they are very active. I think they had to adopt the right approach, right techniques, and hopefully this presentation will show them some light.
We will take a last question from our faculty member, Dr. Arshid Jahangir, who is actually interested in when we talk of a Great Lake, so far the land use pattern is concerned and the Ganges is concerned, because we have a difference so far, even the population is concerned. How do you see to it that it can be actually the knowledge that has been actually worked in the Great Lakes can be applied so far the Ganges is concerned? Your comments, please.
Yeah, I mean, that's the main focus of my paper. I chose my talk not to tell you what I have been doing for 50 years, but to see what are the lessons from the Great Lakes, from the Western technology for India, and how they could be easy, applicable, and cheaper, and practical collectively in groups at selected stations. I think, of course, to apply to Indian situation, you need to have some workshops where we can come and show you how to do it, look at your lab. It comes into the practical aspects. This is just theoretical aspect, and of course you can apply. I hope you will apply. I hope you will apply these techniques and approaches, which are guaranteed to be success in the Great Lakes, and that's how we are hoping that many of the countries will apply the Great Lakes approach. I'm not doing any propaganda of the Great Lakes, but I'm doing propaganda of science.
Okay, I think with these words, I, on behalf of the organizers, Department of Environmental Science, University of Kashmir, Srinagar, would once again like to thank you for giving us a wonderful talk on this despite your busy schedule. I think with these words, we would like to conclude this today's session, and hopefully we will actually meet tomorrow at 10:30 sharp. Thank you to all of you.